Today's video will be the first in a 4-part series where I migrate my entire home network to run fully on MikroTik hardware. In this first episode, we'll be migrating from my existing OpenSense router to a MikroTik router. In the next video, we'll be migrating from my Cisco business switches to some MikroTik switches, and then after that, we'll swap out my Ruckus access point for a bunch of MikroTik APs. And then in the final episode, we'll take a look at the completed setup up and running and talk about my experience. But first, I'd like to thank MS-DIST for sponsoring this video by providing all the hardware you see here. MS-DIST is an official distributor and reseller for MikroTik, along with other brands including Ubiquiti and Teltonika. They offer competitive pricing, including special pricing for trade customers, have received great customer reviews, and have product experts available if you need an extra hand picking the right product or after-sales support. So, if you're interested in buying any of the hardware you see in this video, or any other networking hardware for that matter, definitely check them out, and I'll leave links to all the products shown in this video on MS-DIST store in the description and in a pinned comment. So first up, who are MikroTik? Well, MikroTik is a Latvian manufacturer of a massive range of networking hardware, from switches and routers to access points, all the way to really niche products designed for very specialised applications. And within each of those categories, the products range from super low cost devices such as sub £50 desktop routers, all the way up to absolute powerhouses with 100GB Ethernet interfaces and super powerful CPUs. And what's really cool with MikroTik is that almost all the products, with the exception of a few entry-level switches, run their own RouterOS operating system, which is a super powerful Linux-based router operating system. And unlike a lot of other networking vendors, MikroTik don't lock features and software updates behind paywalls and support contracts. Even their cheapest products offer the full set of RouterOS features. This means that if for some reason you want to run something like a VPN client, or even advanced routing protocols such as BGP on a tiny little £25 router like this, you can. Now, there is a concept of RouterOS license levels, which I'll put on your screen now. Different devices include different license levels, but realistically, the limits of each level are so high that you're likely to hit a limitation of the hardware before you reach the license level limit. So let's take a look at the router I've gone for, and here it is. This is the catchily named MikroTik RB5009 UPR Plus S Plus IN, and this is a really interesting router. As you can see, it's a very small device in a desktop style metal case, which also acts as a heatsink to allow it to be completely passively cooled. Then on the front of the router, we can see we have a DC input for the included 96-watt power adapter. Then there's also a second DC input terminal block on the side here, which would allow you to power this device from a pair of redundant sources. Next up, we have a USB port, which you can use for things like mobile data dongles or mass storage devices to share on the network, or to store data for running Linux containers on the router. What's also nice about this USB port is you can toggle its power from within RouterOS, which could be really useful. For example, you could power something like a modem or smart home hub type device through this USB port and remotely power cycle it through RouterOS. Now, that's all well and good, but what you really want to know is what this has in terms of network connectivity. So let's go through that. As you can see, we have a total of 9 different network interfaces. One 10GB SFP Plus port, a 2.5GB port, and then 7 regular gigabit ports. So as you can see, this is a very good range of connectivity. I can uplink it to the rest of my switches over a 10GB connection. I can then connect my Fibre ONT to one of the RJ45 ports, and use the other RJ45 ports for connecting things such as a future 5G backup connection. What's also great about this particular model is that all of these ports support up to 25 watts of PoE output, and that's going to be super useful for me. Of course, I'm going to be installing separate PoE switches due to the amount of devices I require, but what these PoE ports will allow me to do is power my Fibre ONT and future 5G backup hardware over PoE without having to mess with connecting them to my PoE switches and using VLANs to trunk them to the router. This will be particularly useful for me since my Fibre ONT is located away from my rack in my understairs cupboard and is connected over a Cat6 run back to the rack. Currently, the ONT is powered by a power brick plugged into a socket in the cupboard, meaning that it's not backed up by the UPS in my rack. So what I'll now do is plug the ONT into one of the PoE out ports on this router and then use a PoE splitter like this to power the ONT over PoE. I'll take a look at this later in the video. Finally, you can also power this router using PoE, either using standard 802.3 AF or AT on the first port, or passive PoE on the rest of the ports. Just bear in mind that you can only use either the PoE in or PoE out at one time. You can't power this over PoE and then output power over PoE at the same time. Also just bear in mind that there's a few different versions of the RB5009. The one I have here has PoE, then there's a slightly cheaper one that doesn't support the PoE out function, and then they have another version of this PoE version in an outdoor waterproof case. So next up, let's talk specs. The RB5009 has a quad-core 64-bit ARM CPU with a gigabyte of RAM and a gigabyte of flash storage. MikroTik also provides some pretty detailed performance test figures that show that this can easily route at 10 gigabit with 1500 byte packets, and it can even get speeds of beyond gigabit over an IPsec tunnel. And this is one of the things I like about MikroTik. They provide detailed performance test figures across their range, which makes it very easy to compare devices. And even more useful than the performance figures, MikroTik also provide these block diagrams for most of their products, which are absolutely fantastic for showing how a product is architected internally. This can be super useful to ensure that you use a device in the most efficient way and don't accidentally introduce any bottlenecks due to the hardware architecture. For example, taking a look at the block diagram for the RB5009, you can see that all of the ports are connected to a single switch chip, and this switch chip is uplinked internally to the CPU over a 10 gigabit connection. This means that any switching type activities, so just switching traffic between ports in the front, or things that can be offloaded to the switch chip itself such as VLANs, will all be handled directly on the switch chip. Then anything that requires a CPU such as routing, firewalling or NAT will be forwarded to the CPU over this 10 gigabit link. This is a pretty sensible setup, and it means that you can safely use the ports on the front of the device as a switch. On the other hand, with other routers, you'll sometimes find situations such as this, where each interface is connected directly to the router's CPU. In this sort of device, you wouldn't really want to use the individual ports as if they were switch ports, since the switching would be handled by the CPU itself, which simply isn't going to be as good at switching as a dedicated switch chip. It would be a similar idea to building a router using PC hardware, filling it with NICs, and trying to use them as switch ports. It would work, but you get much better performance using a dedicated switch. Or you might find devices like this, where some of the interfaces are connected to a switch chip, and then other interfaces, such as ETH1 in this case, are connected directly to the CPU. In this situation, you'd absolutely be fine to use the ETH2 to ETH8 ports as switch ports, but you'd be better off using ETH1 for something like your WAN connection. Finally, you can find devices such as this, where they contain multiple switch chips, with some ports on one chip and some ports on the other, and then traffic between them would be forwarded by the CPU. In this sort of situation, you'd want to bear this in mind so that you reduce how much traffic needs to be forwarded between the switch chips by the CPU. There's also some stuff in the documentation when it comes to using VLANs with multiple switch chips, and that's something you'd want to bear in mind if you have a device that's structured like this. The best way to think of these block diagrams would be as if you were building the architecture out of separate devices. With the RB5009 here, you'd have your devices connected to a switch, and that switch would be uplinked to your router over a 10 gigabit connection. Whereas with something like this, you'd have a pair of switches, each plugged into your router over their own 2.5 gigabit connections. And here we are back with the block diagram for the RB5009 I'll be using. I just wanted to do a bit of a showcase of the various block diagrams there, because this is something that's both really good that MikroTik provides, but also something that's very important to check and consider before picking a particular piece of hardware, just to make sure that it'll work well for your particular deployment. So now, let's take a look at the software side of things. Now, RouterOS is not for the faint-hearted. It doesn't connect to an app on your phone and give you a nice friendly wizard to set everything up. Instead, you just get a very basic default configuration and need to make your own configuration changes from there. The default configuration varies between devices, but with a router board series of devices such as this, by default ETH1 will act as a WAN port, the rest of the ports will then all be switched together as LAN ports, and by default it will perform NAT, firewalling and run a DHCP server for LAN clients. On the other hand, their switches will be configured by default to have all the interfaces bridged into one big switch, and devices such as their higher end CCR routers will come with a very basic configuration with a static IP address set on one of the Ethernet interfaces, and that's about it. You then need to configure everything else to suit. To configure MikroTik routers, there's a few different options. You can use the web interface, you can use the command line interface over Telnet or SSH, or you can use Winbox. Winbox is desktop software, which was originally released for Windows only, but they've now released beta version for macOS and Linux too. In this video we'll take a look at Winbox since it's my preferred way of configuring these devices, but you can do basically the exact same thing through the command line or the web interface. So first up, here you can see the Winbox interface, where it will list all MikroTik devices that it can find on the network. As you can see here, it's found my RB5009, and it's showing both its IP address and its MAC address. And this is really cool, because with Winbox, not only can you connect to a device using its IP address, you can also connect purely using a device's MAC address, as long as you're on the same layer 2 network as the device. And this is super useful, since it means you can configure a device without needing to mess around with your computer's IP address settings, and it can also really get you out of trouble if you mess up a device's IP address configuration. So now we can connect to the device. With some older devices, they default to a blank password, but with newer devices such as this, they now come with a password from the factory, It's a randomly generated password and it's printed on a sticker stuck on the device, and I think there's also another sticker buried inside the case somewhere. So it's really nice to see MikroTik moving towards this, since it's much better than having a well-known default password where you'll get people who don't bother changing the default password. So now if we log in, we get the Winbox interface. On the left-hand side here, we'll see the various categories and features. For example, if we click on Interfaces, this will bring up a list of interfaces on the device. As you can see, we have all the physical interfaces on the device, as well as things such as the VLANs that I have configured. We can then click on an interface and bring up performance stats. So performance stats here and various settings for that interface up here. And what you can see here is one of the benefits of Winbox, since it uses this sort of floating window type interface, meaning you can have a bunch of different configuration areas open at the same time, which is really nice compared to having to keep navigating to different pages in a web interface or going back and forward through a CLI. The web interface has a similar overall layout to Winbox, but it lacks this floating window functionality. So yeah, that's the interfaces, but this is where the configuration can be a bit different to a lot of other networking hardware. Because you have a list of interfaces here, but if we click on Bridge and go to Ports, you can see we have another list of interfaces in here. So why is this? Well, this is where the distinction between the switching and the routing side of things come in. The interfaces under the Interfaces section are the network interfaces that are available to be used by the RouterOS operating system. For example, where you'd assign IP addresses and set up routing and firewalling. For example, each of these VLANs has an IP address assigned to the router to allow the router to act as a default gateway. On the other hand, in the Bridge section, this is where we define how the ports on the device are bridged together to act as a switch, and this configuration will ultimately get handled by the dedicated switch chip. So in this Bridge section is where you'd configure all the layer 2 things such as VLAN tags and spanning tree configuration. For example, under the Bridge section, we define the VLANs here, and this is the VLANs that are being used for the switching side of things. Then these VLANs over in the Interface section is the VLANs we'd want to use in a layer 3 context, such as for assigning IP addresses to. If on the other hand we just wanted to switch VLANs but not route them, we'd only need to define them in the Bridge section and not in the Interface section. Then if we click on one of these ports in the Bridge section, you'll see that we have hardware offload enabled. This means that the bridging involving this port will be handled by the switch chip and not the main CPU. If you turn this off, or you're using a device without a dedicated switch chip, you still configure the bridges and VLANs in the exact same way, except the bridging would be handled by the CPU, which would be the same result as if you create a bridge interface under a Linux or BSD system. So it's just a slightly different way of thinking about things. Going back to my analogy earlier about treating a MikroTik device as separate switches and routers all in a single box, you can think of the bridges section here as a VLAN configuration on your switches, and the interface section as a VLAN configuration on your router. Then outside of that, we can go to IP addresses, so we go to IP addresses, and this will show all the IP addresses we have defined on each of the VLANs and interfaces. Or we could go to IP DHCP server, and we can see all the DHCP servers I've set up for all the VLANs to assign IP addresses to clients. Finally, I can go to IP and firewall, and here we can see all the firewall rules, and then on the NAT tab, we can see we have the NAT configuration. So it's all fairly standard stuff. It just takes a little bit of time to get used to where everything is and how all the configuration's laid out. Finally, you have the terminal, which lets you configure the exact same thing as a graphical interface. It's a pretty nice command line to work with. For example, we can run /interface bridge port print, and that will print out a list of all the ports and the VLAN configuration. Or you can sort of switch into one of these configuration paths. So if I were to run /interface bridge, it'll switch me into that area, and then I can simply run port print to run the same command. And of course there's obviously commands to edit and change all this sort of stuff to add interfaces. It's all fairly simple once you get your head around it. Now if you want to do things such as bulk update a bunch of, say, network interfaces, you can definitely do that. But instead of the way it would work on most more conventional switches where you specify a range of interfaces, with RouterOS you would use the scripting functionality. So here you can see the documentation on the command line scripting, which I'm not going to go into in this video, but you can do things like loop over interfaces that meet certain criteria and then run commands to set configuration on each of them. So it's significantly more powerful than the command line of most networking hardware, but it also has a much steeper learning curve. And really, I'd say that's the main overarching thing with MikroTik from the software side of things. It's great, it's super powerful, but the learning curve is pretty steep, and it's very different to most other network kit on the market. Whereas most other vendors kind of take inspiration from each other in terms of configuration and interface layout, MikroTik very much does their own thing, which is cool to see, But if you're considering using MikroTik Kit, you're going to need to do a ton of learning, even if you're already pretty experienced. What I'd recommend is if you're thinking about getting into MikroTik, just take a look at some videos on how to configure them before you commit to buying, just to make sure you're going to be able to pick up the configuration side of things. Potentially check out a few videos on key things like configuring VLANs and see if you can get your head around it. In terms of resources, MikroTik have their own YouTube channel, and there's also channels such as the Network Berg who have fantastic RouterOS tutorials, which helped me out massively when figuring all this out. Then one final thing I'd like to show here is this button up here labelled Safe Mode, and this is a really nice feature of RouterOS. Safe Mode allows you to make changes without risking locking yourself out of the device. It's a similar idea to switches where you need to write the running config to memory for it to persist across reboots, but it works a bit differently. Normally, within RouterOS, any change that you make will be applied and saved instantly. On the other hand, if you turn on Safe Mode, changes will still be applied instantly, and then when you exit Safe Mode, those changes will remain applied. On the other hand, if you make a bunch of changes in Safe Mode and then your session terminates abnormally, such as where you make a configuration change that locks you out of the device, all the changes you made in Safe Mode will automatically roll back. The only downside I've found is that there's sometimes configuration changes that will drop your Winbox or SSH session, even if you aren't locking yourself out of the device. In these scenarios, you can't really use Safe Mode since it'll roll back the changes when your session drops, but Safe Mode still really does have its place, and it's particularly useful for things like configuring firewall rules, where it's very easy to accidentally lock yourself out. So this is a really nice feature to have, but unlike other devices where they force you to use this sort of system to permanently save changes all the time, with RouterOS, you need to explicitly decide to use Safe Mode if you're wanting to make any risky configuration changes. So there you go, that's the software side of things. It's definitely quite different to a lot of other networking hardware and it has a pretty steep learning curve, but now that I've been playing about with it and getting a bit more experience with it, I actually quite like it. It's different, but it's quite good. And now, let's take a look at the power consumption. Right now we have the router booted up with two network interfaces connected at 1 gigabit per second. And with this, it's drawing around 9.2 watts from the wall, which is really good. Of course, this is currently idling, so it'll increase slightly if the router is handling a lot of traffic. If we run a speed test, where we're sending about a gigabit through the router, you'll see the power consumption is increasing to about 9.6 watts or so. I've also found that if I connected ETH1 at 2.5 gigabit rather than 1 gigabit, the idle draw would increase to around 10 watts. And you'll also see the power draw slightly increase for every Ethernet port you have connected. And of course, also bear in mind that if you use this power devices over PoE, you're going to see significantly higher power consumption. But this is still very impressive, and it's less than half the power draw of my current OpenSense router. Now, you may be looking at this and thinking, but you mount everything in a rack, so why haven't you gone for a rack mount model? Well, this is actually rack mountable using the optional rack mount kit, which at under £10 isn't particularly expensive. At first glance, this rack mount kit looks pretty weird. We have the lugs that attach to the router, and then we have these holes over here to screw into the rack. But then we also have these additional holes over here, and this sort of weird bit of metal in here. That's because this kit is a really clever design that can be used to mount anywhere from 1 to 4 separate RB5009 along with cheaper L009 router in a single one-use space. So if you want to mount a single router, you mount the complete ears onto each side, like that. Like that there. And you could either mount the router towards the bottom or the top of the bracket. You could then mount a second router above or below it into the same bracket. And then with that, the end result would look something like this. Then, if you wanted to mount 3 or 4 routers, or 2 routers side by side rather than stacking them, you'd have something like this. You snap off this section of the bracket along the slightly weakened line, which would leave you with just these 2 smaller mounting brackets that would go on either side of the whole assembly. You would then break out these metal pieces, which would then give you these pieces that would join the routers together in the middle. So it's a pretty clever design. Rather than needing to put a bunch of different parts, they can sell one part that you can modify to fit however many routers you want to install. Now, when I first saw this, I was a bit worried that it would be quite flimsy along this weakened line here, or this part that's designed to be broken out, but to be honest, it's absolutely fine. Even the weakened areas are pretty thick, so I'm not worried about them breaking off in use. In fact, I can practically bend that, I can barely even bend that with my hand. It is really quite strong. And now here we have the router mounted on the rack mount bracket, and it all seems absolutely fine. It feels pretty durable. I've got no concerns about that at all. It feels really solid. Now, there's one final thing I want to quickly cover with this, and it's something some people might be wondering after seeing this rack mount design, and that is, can you fit it into those sort of mini 10-inch racks that a lot of people are kind of playing with nowadays, sort of trendy new home lab thing? And the answer seems to be, it depends. I've not got one of these racks to test, and it's not really something I'm particularly interested in, but it seems as though those sort of 10-inch racks, they're not very standards compliant. They're very much designed to have the rack from one manufacturer, and you use the same manufacturer's patch panels and accessories in the same rack. They're not really designed for mounting third-party equipment like this. And looking online, it seems like some people are able to get this to fit by simply removing the outer bits of the rails and just using the small inner lugs on the router. They can get it to fit into their 10-inch racks, whereas other people are saying it's too tight and it doesn't fit. And that's just because, again, there's no real standard with these racks, so there's a lot of variance between the sizing. So I thought the most useful thing I could do is just be to measure mine, so you can kind of see what size it is, and if you wanted to use it in your own mini rack, you kind of go off my measurements to see if it would fit in your particular rack. So measuring from the metal on this edge to the metal on this edge, including the metal for the rack mount bracket, we're getting round about 22.5 centimetres or 225 millimetres. Now it's very much on the line there, so you'd probably want a bit more clearance than that to actually get this to fit reliably into a rack. But yeah, that's kind of the size of it there. So if you want to try and fit this into a 10-inch rack and the width space between the vertical rails in your rack is bigger than that size there, you might actually get away with it. But just bear in mind, this is not designed for that. This is not designed to fit into these 10-inch racks. It's just a side effect of this rack mount bracket style. So I want to kind of cover that for people who might find it useful or might be considering putting this in a 10-inch rack, but it's not something that's really officially supported, so it could be a bit hit or miss. You would really need to be very, very lucky and check the measurements. But yeah, just thought I'd quickly show that. Okay, so now here we are in the garage with my comms rack, and here we have my old OpenSense router we'll be replacing with the MikroTik RB5009. So I've already set the new MikroTik router up with basically the same config as this, so the same subnets and all that kind of stuff. So in theory, I should just be able to take this out and directly swap in the MikroTik router, and it should all just work, so we'll see how that goes. So we've got the WAN connection here that goes to my Fibre ONT, that comes up into the patch panel, into this port here that runs the understairs cupboard. I'll be eventually powering that over PoE later in the video, but yep, that's the ONT in there. And we've got this SFP plus DAC cable that comes out into my switches that are all connected together. And these eventually will all be replaced with MikroTik switches as well. So in theory, all I need to do is power this router down, take it out, stick the RB5009 in, connect it all up, and it should just work. So let's see if that should means it actually will or not. And there we go, that's the router now installed. So it's all installed in its rack mount kit. We've then got the power connection, the SFP plus DAC cable that connects down to the switches, and the WAN connection connected in here that, as before, comes up into the patch panel where it's patched through to the ONT in the understairs cupboard, which is now being powered over PoE, which we'll take a look at in a second. But yep, that's it all installed and working. And now here we are in the understairs cupboard with my Fibre ONT. And unlike previously, where it was being powered by this power brick, it's now being powered over PoE. So the Cat6 cable comes out this link, so this connection runs over to the rack, runs up into that PoE splitter we saw before, and then the power and data individually come out and power up the ONT and connect to the network. And it's working absolutely brilliantly. So now if I have a power cut, lose any power in any of the circuits, the UPS in the rack will continue to power the rack, and then the router, which is powered by the UPS, will continue to power the ONT over PoE. So realistically, I'm completely now resilient against network outages during a power cut, which is absolutely brilliant. And this is definitely a really good option for situations like this, where you have a Fibre ONT that's located far away from your main rack or your UPS, but you still want a battery back to the ONT without having to have a separate UPS in here. It works really well. So there you have it. We now have my brand new MikroTik RB5009 up and running, and it's working perfectly. I mostly just replicated my existing config from OpenSense into RouterOS, so it's a pretty drop-in replacement, but everything seems to be working absolutely fine, and I can't wait to play about with this more in the future. There's still a bit of additional config to do around setting up some WireGuard VPNs and things like that, but I'll do that after the video, and I'll talk about that in my final video about how I experienced the whole setup process. So yeah, hope you found this video interesting or potentially useful if you've been considering MikroTik hardware, and stand by for future videos where we'll take a look at the switches, access points, and then finally take a look at my completed setup all up and running and talk about my experience. But all left to say now is thank you very much for watching, and if you're interested in buying any of the hardware shown in this video, definitely check out the links to them on MS Disk Store in the video description.